Amazing, you've already studied 3 laws, and that is quite a good progress, but still we need to keep things moving. We still have 3 more laws that we are going to study in this session for your understanding also, and also to make sure that you are really competent enough in this topic. Just a quick recap. In the previous session we studied the multiplication law, the division law, and also the exponential law. And I remember what we said about the multiplication law. We said that whenever we've got a case like a to power m and it is multiplied with a to power n, that one is always equivalent to a to power m plus n. I hope that you do remember that, and that you've gotten how to apply that. Then again, for the division law, we said that whenever you've got a case like a to power m and we are dividing it with a to power n, that one is always equivalent to a to power m minus n. What about the exponential law? Remember that we said that when we've got a case like a to power m and then again that is raised to power n, that one is always equivalent to a to power m to power m multiplied by n. That is what we studied in the previous session. So let's now move on to 3 other laws that are as well important, and laws that will be applicable in the questions that we'll be doing next. So we have the 4th law right here with us, and that is the zero index law. So there are some cases that you are likely to get. As you tackle questions, you are likely to get something like x to power 0, and then you are supposed to give the value of that, or even you get the value of even a big number like 1563 to power 0, and then you are supposed to give the value of that. And sometime you may wonder what would be the value of this one, because for others it's very easy to calculate. For instance, a case like 2 to power 2, we know that that is 2 multiplied by 2, which is 4. But what about for a case like this one? That is now where we get now to apply this law, and that is the law that is called the zero index law. So whenever you are given any number a and you are told that that number is raised to power 0, always know that automatically the value, or rather the result that you get from that, will always be equal to 1. Therefore, even for these other values that we get from here, that is x to power 0, that one should also give you a 1. Even for this value 1563 to power 0 is equals to 1. Any number, provided whether it is small, whether it is big, it will always result to 1. Even for a case like 2 to power 0, that one should always give you a 1 also. But this formula does not apply when a is equivalent to 0. So the only exemption that we have is this one. So it's important to note that the zero index law suggests that whenever you've got any number a to power 0, it will always be equal to 1. Let's check in the next formula, or rather the next law, and that is the 5th law. And we have it right here with us. For most of the cases that we've dealt with, they were involving mostly numbers that are there in the numerator. But what again if we have some values that are negative? Suppose we've got something like 2 to power negative 3. How would you deal with such a number? How you deal with such a number, that's now the point that we get to apply the negative exponent law. You see, this is an exponent and this is a negative. So this law suggests that when you've got a case like x to power negative a, this one is always equivalent to 1 over x to power a. So this is the law for the negative exponent law, and it's very testable and very examinable. Therefore, it's very important that we do understand how we are even supposed to apply that. So when you've got a case like this one, 2 to power negative 3, that one should be equivalent to 1 over 2 to power 3, and that is going to give you 1 over 2 to power 3. That's going to give you an 8. Similarly, when you've got a case like 1 over 3 to power negative 3, how can you apply this law or this formula to get a value where we don't have a denominator? The way that you are supposed to do that is just to take the value that is here in the numerator, which is 3 to power negative 3, but now this time round, because we've taken this one to the numerator, we negate the sign from a negative to a positive to get 3 to power 3, which would give us 27. So that's how we get to apply this law, that is the negative exponent law. And finally, the final formula that I wanted you to really understand is this one that we have here, that is the fractional exponent law. You know, there are some points, or rather there are some cases that you are likely to get different numbers. Let's take even a case like 8 over 27, and you get such a number and you find it is multiplied by 2 over 3. How would you deal with such a number? The way that you should deal with such is by now applying this formula that I'll teach you right now, and that is the fractional exponent law. Let's check what it suggests. It suggests that whenever you've got a case like a over b, or rather generally, to make it easier for you, when you've got a case like a to power m over n, this one will always be equivalent to the nth root of a to power m. I hope that you do really understand this, that when you've got a certain number and that number it is raised to a certain power that is a fraction, what we usually do is that we always take that number, which is a, and then we power it by what is there in the numerator, and then we find the nth root of that. Let's take a case scenario and a practical example for that case. Suppose that you've got something like a number like 20, or let's take a number like 8, and then you are told that this 8, it is raised to power 2 over 3. How should you deal with this one? The way that you deal with this one is that you take the root as this one. The root will now be 3, therefore we'll be finding the cube root of 8. Therefore we write the sign of cube root like that, then we write 8, and then the power that was here in the numerator, we put it right here where we have the 8, such that we have 8 to power 2, and then we find the cube root of that. And what are we likely to get as the value of this one? Then that's now when we solve this one, then we get the value of that. This one, it's like finding the cube root of 64, and what would be the value of that? That's now how you get to solve that. But the idea is that whenever you've got such a case, remember that this number that you have here, that's what we usually get right here. This number that we have here, that's what we write here, and then what we have here is the denominator of this fraction, that's what we have as the root, and what we have here is the power, that is 2, that is the number that is directly linked with now the power of that fraction. Let's actually get to also tackle this in a different way and see whether it is going to give us the same result with this one. Before we actually tackle this one, remember when we have something like 8, this one, it is the same as 2 to power 3. Now this is a different concept that I want to introduce, but we've already tackled that to see how these formulas get to relate and get to connect. So we have 8, you see 8, it is equivalent to 2 to power 3, and then we have 2 over 3. Now here we can use a concept that we had already studied, which is right here. Let me take you back. That is the exponential law. That is whenever you've got 8 to power m multiplied by n, that one is equivalent to 8 to power m n. Let's go ahead and apply that right here. So when we've got such a case, therefore that implies that the value that we get here is 2 to power 3 multiplied by 2 over 3. Therefore this 3 we divide by 3, we divide by 3 to get 1, and finally we remain with 2 to power 2, which is 4. You see, this value that we get for this case using this strategy, we get it as 4. And actually you can compare whether after finding the cube root of 64, whether you also get a 4. You can confirm that to see how these formulas get to integrate. For this one, I believe you can be able to try it on your own, and once you try it on your own, just remember to give in the answer that you get. But then again, towards the end of this video, just below the questions that are here, I'll also provide the solution for that. But just a quick recap to enhance your understanding for that. What we've said is that whenever you've got a case like x to power 0, that one will always give you a 1. For the negative exponent law, we've said that whenever you've got a case like a to power negative n, this one will always be equivalent to 1 over a to power n. And whenever you've got a case like this one, a to power m over n, that one will always be equivalent to a, and then you find the nth root of that, and then you power the value that is inside by powering it by m. So always remember that what you have here is the numerator, that's now what you have as the power, and what you have at the denominator, that's now what you always put it there as the root. And now I want to give you just a bonus formula just to try to relate these formulas together. Remember that we had this concept that is right here from the product, or rather from the first law, that is the multiplication law. We said that when you've got 8 to power m multiplied by 8 to power n, we have it as 8 to power m plus n. And when you've got a case like 8 to power m divided by 8 to power n is equivalent to 8 to power m minus n. But what if we've got a combined case? Let me actually call it combined formula, or rather combined law, for the purposes of having consistency. Suppose that you've got something like 8 to power m, and then it is multiplied by 8 to power n, and then it is divided by another figure, or rather another value, a to power x. What would be the value of this one? The value of this whole the value of this whole sum that we have here would be equivalent to a to power m plus n and then minus x. Notice that what we've done for all the values that are above this line, what we call the numerator side, we add them, but then again everything that is below it, then we minus. But what we are dealing with is now the powers for that. Also this one, it's a formula that you are likely to be tested whether you really understand it, and actually we are going to do so many questions just to enhance your understanding. Just below, or rather just in the next sessions, in the next session that we have, once you click the button that is written next, you'll be able to find some simple questions that you can be able to do, and some exercises that you can be able to do, just to enhance that you really understood on how to apply these formulas. And then from there we'll now also get to tackle some more questions that would be a bit challenging, just to ensure that you do really master everything well. So see you next as you get to exercise and as you get to do some practices.